Yes, I know you've not yet started your chemistry paper 2, neither has anyone else. So let's get on with it. This is everything you'll need to know about the organic chemistry topic if you're doing combined. Organic chemistry is the chemistry of carbon compounds. It's called organic chemistry since everything living is based on organic compounds. Our focus in GCSE chemistry is on hydrocarbons. As the name suggests, these are molecules that contain hydrogen and carbon only. Crude oil is actually a mixture of just many different types of hydrocarbons. Remember, crude oil is a fossil fuel. It was formed mainly from plankton that died and was buried in mud. There are two types of hydrocarbons, alkanes and alkenes. Most of the hydrocarbons in crude oil are alkanes. Alkanes are saturated hydrocarbons. We call them saturated because every carbon is completely filled with hydrogen, and that's because there are no carbon-carbon double bonds, only single bonds. Know the general formula for all hydrocarbons? It's this CnH2n plus 2. You also need to memorize the names of the first 4 hydrocarbons: methane, ethane, propane, butane. Noticing they all end in ane because they're alkanes. Now, that mixture of different hydrocarbons, that is crude oil, needs to be separated so we can use each of the individual fractions for what they're best used for. Those useful fractions of crude oil include liquid petroleum gas, petrol, diesel, kerosene, heavy fuel oil, bitumen too. So if you had all of those in one single liquid, how would you go about separating them? We make use of the fact that different lengths of hydrocarbon have different boiling points. The longer the hydrocarbon and therefore the bigger the molecule, the stronger the intermolecular forces will be between those molecules. Stronger intermolecular forces mean more energy is required to overcome those intermolecular forces when you make that thing change from a liquid to a gas. And if more energy is required, it has a higher boiling point. So those shorter hydrocarbons have weaker intermolecular forces and therefore lower melting and boiling points. The longer hydrocarbons have stronger intermolecular forces and therefore higher melting and boiling points. So fractional distillation makes great use of that by heating everything up and then passing those evaporated fractions through a fractional distillation column, which quite simply just has different levels with different temperatures. The higher you go, the cooler the temperature. So as the fractions travel up the column, when they get to a temperature that's cool enough, below their boiling point, they will condense. And that allows us to collect those condensed fractions at their different levels, effectively separating them. Other than melting and boiling point, make sure you also understand trends in, first, viscosity, basically the thickness of the thing. The more viscous something is, the less runny it is. The longest fractions are the most viscous, therefore the least runny. Shorter fractions are the least viscous and therefore very runny. Second characteristic to make sure you're aware of is flammability. The shorter hydrocarbons are much more flammable. They can be oxidized and therefore combust a lot more easily than those longer hydrocarbons. Also know the reaction for the combustion of any hydrocarbon is always the same. Hydrocarbon plus oxygen gives you carbon dioxide and water. Nice and simple. On to the last bit now. The shorter length hydrocarbons are in much higher demand than those longer length hydrocarbons. Those shorter ones include the ones that are used for fuels, for example, like petrol and diesel. We can use this process called cracking to take our longer hydrocarbons and